My name is Nikita Belkovskii. I'm a QA engineer here in Exness. I am working as a QA engineer since 2014, and during these almost 10 years, I tried different types of projects, starting from fail-safe aviation software and ending with high-loaded warehouse management systems. And here in Exness, I'm working on a trader area platform. Also, I am a public speaker since 2017. And yeah, I have spoiled this slide. I want to know more about you. How many testers are there? Please raise your hand. That's a lot of them. That's unexpected on a testing party. Okay, and for you, my testing friends, which one of you, or who of you use pairwise in their daily practice? Not so many as expected, but okay. We will talk a bit deeper about pairwise and other combinatorics that we can use on our projects. So the question is what it is and why do we need this? Yeah, the basics. Say we have a web project, web page with options like language, font size, etc. We have a lot of options how to combine these inputs into our system. Well, the easiest way is just to take everything just once, and thus we will get to 5 test cases. And probably not enough, obviously, because some of languages with small sizes, their symbols can be not readable. At the same time, combining all of them together, we will end up with 80 test cases that may be too huge and will take too much time to do regressions enough often. So pairwise, as I think a lot of you at least heard about that, it sounds like a good compromise, as we just end up around 20 and 22 test cases, and that should be enough for most projects. And it may sound not as cool. 80 to 20, as this example. Some studies that one of the studies I used for today's talk, they show us this example: 120 binary inputs were drastically decreased to just 10. But that's the basic that probably most of you know. But there are a lot of other ways how we can go with combinatorics. Say you can combine more than just 2 inputs to get more thorough testing, and there are even more options you can get to your project, probably to make the testing less strict but faster. And we will talk more about them a bit later. Here is the thing: why does combinatorics work, and why do we need to combine inputs? Why do we need to bother about this? This is because inside your system, the inputs, they interact. They have interference, and that interference is a basement for issues. Say you have 3 inputs and 3 outputs, but a lot of issues can be a consequence of combination of some of them. Okay, another question that I want to ask: how many of you just do not bother about pairwise and think, that's okay, I'm absolutely okay with using just random approach. I just randomly combine inputs. Don't be shy. Raise your hands. Yeah, I see there are some. For those who probably think that's a crazy approach, this is not as bad as it may sound. One of studies shows us that if we try just go with pairwise and simultaneously we try to go through some iterations with random approach, we will see that at the moment we have the full pairwise coverage. We have 88% covered by a random algorithm. Here, in this case, they tried a bunch of inputs inside the word text processor. So 88%, may sound not as bad as you probably expected. Another study, this is meta-research, it shows us that picture is a bit more complicated. They tried different. They examined different algorithms for pairwise generation, and they tried to calculate expected amount of expected percentage of cases that will be covered by a random suite. And we can see a couple of things here. First, it almost never gets below the 70% point. At the same time, we see that the line here it's unstable. This is because different pairwise algorithms they lead us to a bit different results, and thus we cannot rely on a random approach each time. At the same time, we see that there's a kind of trend that the bigger suite we get, the better random coverage. Probably you may think that, yeah, that's a good idea to go with random if I have a huge amount of inputs and huge potential pairwise suite. But another study shows us that probably that's also not the case. What's the problem here? They tried to go from the other side. They generated test suites using Latin squares method for pairwise, and at the same time they generated they tried generating full random suites to cover everything that pairwise suggests, and they saw that the bigger potential pairwise suite, the bigger iterations, the more iterations it is required to get to the same point using randomization. You probably saw it's here, the very long tail. This is because randomization it requires too many effort to get to the same point. So for now, it seems like probably randomization is not the best option. But interesting moment that these guys they have this conclusion that randomization still can be a thing if your system under test is rapidly changing. They had a graphical user interface as an input, and they think that if you use something slow and heavyweight like Latin squares, and they have this rapidly changing system, it's probably worth working with randomization. And also, if you are living in 1996, just because unfortunately this study gives us interesting math, but at the same time, the guys hadn't tools we have now to generate combinatorial suites in more conscious approach. Okay, probably random is not the option for most cases. But why are we so sure that pairwise? There are a lot of books and articles that say that pairwise is one of your main tools. Why do people so rely on this technique? Probably it's not enough. Okay, probably you have seen this study before. It is a study from legendary book, Practitioner's Guide to Software Test Design by Lee Copeland, and he said that, wow, look at this. These guys show that pairwise can drastically decrease risks. What is the study about? They tried to examine 50 years of post-mortem studies and see if issues that were found on production, these are medical devices, what is even more spooky, what can be done with that? Can combinatorics help us with that? And they show us that amazing result, that pairwise probably can cover most of the cases that were found during these studies. But there are two problems with this research. First of all, you see that 68%, the blue part, the dark blue part, they are not enough detailed to let us know if pairwise or any other techniques can help us. That's the first bad thing. The second bad thing is that we cannot say that pairwise good or bad because it's just a post-mortem study. They tried to examine things that were already found. But what if pairwise or other more strict techniques were used before the software gets to the production? So, but there are a lot of other studies, and say this one is well detailed. It's a NASA project, the Deep Space One. This is one of the experimental projects, and they had the apparatus they sent to space had four subsystems: convergence, correctness, interface, and engine. What do we see here? The dark blue columns. These are columns about pairwise. Especially, they caught some two-way bugs using this in these systems. And you can see that the first two subsystems, convergence and correctness, pairwise was a thing that helped them a lot. At the same time, you can see that there were a lot of one-way bugs, just single bugs with that are caused by just logic problems, and they are more one-way bugs than the two-way bugs. What do we see here is that you still need to think a lot about logic behind the scene. Yeah, you still need to think about how to cover your flows. But at the same time, pairwise can help you with combinatorial issues. But in the interface and engine part, you see we have light blue columns, and they are pretty huge. These are bugs that were not caught by their regular testing. And again, these were bugs that are related to logic inside system and related to configuration. They caught them another way during the dev studies, the dev stage. Sorry, but we see that pairwise is not a silver bullet for solving all our problems. Okay, let's get to the stricter side. Another interesting study shows us a couple of things. I need to say about the technique they used. They seeded bugs inside the existing software, so they knew where the bugs are. And this helped them to examine the system deeper and the results of the testing more consciously. And they had two systems under test. They tried loan arranger system and data management analysis system. They tried different ways to combine their tests, and we see that yes, most of the combinatorial bugs can be caught but two-way. At the same time, there are 3, 4, and even more than 4 ways. We will talk about why did this bug appear a bit later. But we see again that didn't find the usual one-way logic-related issues are still there, and they are even more than pairwise or three-way issues. Okay, sometimes you see that 3 ways and 4 ways testing it can be the desired way. And here's another study, probably the most complex, or one of the most complex that I'm among others. You can see they tried to compare different information about different projects. And here on this graph, we see that pairwise can drastically decrease your potential issues compared to the one-wise only approach. At the same time, it's probably okay to stay at pairwise for, say, browser, even at, say, 75 level. At the same time, 95% for medical devices probably not enough. You remember a couple of slides ago, I showed you that there were a lot of failures on production during that were examined by another study. So I don't want to be below a medical device that tested for 95%, and they usually use a stricter approach. Okay, let's talk about interactions. We saw that 3, 4, and even more ways testing is sometimes it is required for your project. Why does this happen? Because the interactions inside your system, they're not only two-way interactions. Yeah, they're not x and y may be related to z, and to understand what's going on inside your system, you probably need to examine what's inside. And this study, I want to refer to it again. These guys who used error seeding, they did this. They examined the things that were happening inside, and they saw this spooky picture. You see that there is almost no two-way interactions. 3, 4, and even more are happening inside. Of course, we do not see so many bugs appearing in 4-way or more way. This is because a lot of interactions doesn't mean that you will have bugs based on it. But this is the basement for your bugs. If you have, say, the simplest possible application like Hello World or CRUD, we just reading and writing into a database. There's not so many interactions, and probably will be okay with one way. And even the worst developer will not be able to do a 4-way bug just because there's nothing happening inside. At the same time, if you know that this is inside your system, you are probably interested in strictening your combinatorics in your tests. Okay, another game. I think that not all test cases are equal. So which case will arise most often in this case, for this application? This is a word text processor. We have a bunch of binary inputs. This is a setup page where you just activate and highlight and other options. So what do you think, guys? Which case among all of possible inputs will be the most popular among users? You can say it out loud. I'll double it into a mic. Status bar. Okay, one option. Yeah. Other ideas? Scrolling. Yeah, that sounds. That's a feature that they use a lot, I believe. So any other option? Okay, so no options. Okay. It's probably hard to just get straight to the thing. Your ideas were right to some extent. You said about just a single binary input. You said just a single option. That this will be our points 2, 3, and 4. The most important case, the most popular case, is the default one. Just because users they usually don't even go to the setup. They just start writing text, and after that probably they will get to this show options, and here they will try switching just a single point. So probably if you have a lot of options, a lot of potential test cases, you don't need to think about all of them. Probably you just need to cut some of them at the end of your pairwise suite. They're not so important. Okay, we saw that sometimes it makes sense to go with a stricter testing, sometimes not. How can we get to a sweet spot? How can we lie probably somewhere between 1-way, 2-way, and more ways? Another question. Say we have this example, 22 pairwise test cases, but we have time to create only 18 of them. What would you do in this situation? Go with random. Yeah, that's a good idea. We talked about it. Other ideas?
18 is pretty enough.
Huh?
18 is pretty enough.
Just stop. Don't worry about which cases are there. Just cut randomly. Okay.
Equal decrease between each level.
Equal decrease.
I mean, there are three level tests, so 1, 2, 3 from each one is deleted, and that's it.
So you want to cut some values from the inputs. From
22, so from each group you delete something and that's it.
From some. Okay, that's a pretty similar idea. Yeah, to cut some test cases based on the inputs. Yeah, it is. If there are no ideas, I will go to technically you
Remove the default option?
remove the default option.
Because the developer probably tested with the default.
Yeah, that's a good idea. That's one of the things that I will talk about. Well, technically, all of your ideas will be covered just a minute. Parallel run. Yeah, that's not about combinatorics itself, but yeah, that's thing that I use a lot every day. Exist on PyTest with 10 threads. Okay. Yeah, the simplest way, of course, is one way. If you think that there's little to none chance to get a combinatorial bug, of course, you can just go with one way. And I do this a lot. Again, it's just if I have a test with a good coverage of logic, I just parameterize it one way, just not to spend too much time on execution time. About defaults, yeah, there's probably not default, not necessarily default, but just some basic values that will be appear often. Say, one of the countries or one of the languages is more popular among your customers. You can fix these options. And after that, you can go with switching another points. So here, in case of matrix 3 to 3, there will be 9 pairwise test cases. Instead, we have base choice testing test cases, just 7 of them. Some guys suggest us using partial pairwise. Say you just go with pairwise for the most important inputs, and fill rows with one wise way. And with this approach, you can get to the other side. Probably, if you want to cover some three-way potential issues, but don't want to get to point where you have too much test cases, you can combine just two wisely things, and after that, make your suite bigger with 3 wise. Okay, for approaches, I just scratched a bit this, and I cannot go deeply, unfortunately, to all algorithms that can be used for pairwise or any otherwise suite generation. Not because they are too much, and it will take another talk or two to cover them. At the same time, I just want to point that the algorithms, they work differently, and sometimes you probably need to understand which one is better for your case. If say you have slow tests, so probably you don't need to go with less stricter testing, but just to switch algorithm. And just for comparison, there are 2 combinatorial strategies they used. Non-deterministic and deterministic. The deterministic one is obvious. Each time you run an algorithm, it gives you the same suite. Non-deterministic gives you a different suite each time. Why non-deterministic probably is your case is just because sometimes they are just more effective in some input suites. At the same time, we have another separation, another 2 types of algorithms. They are iterable and non-iterable. Non-iterable, obviously, they just create a suite in a single iteration, and the iterable ones they run several times to get the suite. So this is where you can again stop your testing somewhere in the middle. Especially for some algorithms, you can define the basic test cases that is best your risk management, and after that you can generate suite based on them, and stop somewhere in if you need more, if you need to make the suite shorter. And as a last chart of my talk, this is just a cool graph of how different coverage criteria follow each other and how they supersede each other. At the top, you see all combinations, the way where we have the most possible cases, and going down t-wise, say 2, 3, or more, to each use, like say partial pairwise. Okay, the conclusion. There are a lot of ways you can do this combinatorial testing. I hope I showed you something, some points to some points of interest. And what to do? As we saw, there are sometimes a lot of interactions happening inside. So you should analyze your product. You know, usually pairwise, threewise, all these combinatorics, these techniques are referred as a black box techniques. That's a fair assessment, but to make your testing more efficient, you probably need to go to the guts of your system. And that's what I want from you, to go to your developer, probably to your system analytics, to talk about the inners of your system, and probably go and check the code by yourself. This is what I do from time to time. Just I'm a happy tester because I'm using Python for testing, and most of our backend is created on Python, so I can just go and check the code. The second point is consciously select parameters, and the third, configure test. The studies that I examined today show us that sometimes some issues with test setup or with the flow covered inside test cases, it can lead to bugs. Unfortunately, combinatorics cannot fix all your problems. It's just another tool in your pocket. And analyze test results. You know, the feedback loop is still a thing. If you have some issues that appear in, say, on production, or some of steps of your testing flow, probably this is due to combinatorial issues, and you again need to go to the point one and analyze your product. And for those of you who don't care too much about threewise and who just stick with pairwise, with a high chance you are okay with that. The studies show that this is the technique that covers most of the combinatorial issues. But you need to, I think, you need to think about it as just as another tool, because 98% that we saw on this study, the Copeland referred us to, seems to be not the real case. With a high chance, we will be somewhere around 50% of issues that are covered with combinatorial issues that are covered with two-way testing. And there's no deterministic approach, unfortunately. Sorry, I tried to find an algorithm to fix all your problems, but this is not the case. But you know, they don't pay us just for reading books and articles and blindly approaching, using the techniques. They pay us for artistical approach, for the way we are thinking, for our professional intuition, and that's why I like my job. So that's all. Thank you very much for listening. And your questions.
And can you offer maybe some online resources that can generate your suits? So I seen one. It sounds like pairwise test generator or something. So there's a lot of algorithms. So can you offer us one or two resources?
Yeah. I usually, when I try some online resources, I tried a couple of them during preparing this talk. You know, they usually really inconvenient. I had them just because it's hard to input stuff and generate. So if you want to use, say, pairwise, I'm almost sure that your language, if you're creating an autotest, is already have such kind of tool. Say in Python we have.
You're talking about libraries. right?
Library, a library that all pairs pi, if I'm not mistaken. And again, as with a high chance, it will be enough for you, and you don't have to go with sophisticated approaches like ATG, say. That's what's here, and that's an algorithmic non-deterministic approach. This one that uses some basic cases. So I think that you will be absolutely okay with that. As for more complicated stuff, say for one-wise, I use a lot just one-wise just to combine things that I'm sure there will be no combinatorial blocks. I have just created my version of zip function. The zip function in Python, it has one issue. If you have tuples with a different length, it stops right where the first tuple has ended. So I just created a function in a couple of lines that goes looped and generate me this kind of stuff.
Oh, yeah.
It sounds like ChatGPT. Like it's very easy way to.
Yeah, that's a good idea.
Like you just throw them your.
I didn't thought about that. I am probably the guy who slowly rolling into this kind of stuff. I just learned to ask ChatGPT a couple of stupid jokes, and that's all. But that's a good idea. Try ChatGPT to generate.
Like you can ask him to give you. You can ask it to give you like examples in your language. Let's say you can write like in plain text and tell him like give me like Python arrays of combinations, like even tests. So like it's pretty good at that random like non
cool
actual code.
So if you execute your a subset of your test suite, how does it work in continuous integration? So, for example, today we found some bugs because we executed exactly this subset of tests, and tomorrow next build just ignores those tests, select others, found nothing.
Sorry. Are you talking about a non-deterministic approach, or what? Because in my as I see testing, you have like a build of tests that is it's pretty stable. I hate flaky tests, and that's why I usually don't go with say. A random choice of test inputs. It's better to go with the same thing. So if you have your test failed, I think it's not important. It appeared say in GitLab during continuous integration or where. You can just go back and rework your inputs and generate stricter suite. Probably there's another problem if you possibly using something that generates pairwise inputs on the fly, and this is something not deterministic, and you probably sometimes see bugs, sometimes not. That's probably the issue, but I don't think that's a thing that appears often in projects. Personally, me, I have never seen this kind of stuff, but at the same time, I saw flaky tests due to random choice in Python.